can also check the resistance by using a multimeter. And when I measured the value, I got around 28.3.
So today we will be introducing ourselves to electronics, and to start off, what is resistance?
Some conductors are better at carrying current from other conductors. For example, copper carries current better than carbon does. We can see this by conducting an experiment using a power source, a multimeter, a carbon, and connecting wires. First, we connect this power source to the switch, then the switch to the resistors, and connect the resistor to the multimeter, and we leave this without connecting it, because if we connect this, then the current will pass. Now we're going to measure the current that passes through the resistors. Now we can connect the power source to the multimeter, and we have different volts, like we have 1.5, 3, and 6. We're going to measure the current passing through the resistors when we supply this much voltage. And we turn on the power source and the switch first. Okay, now we're going to measure the current passing through these connecting wires through the resistor by supplying voltage from the power source. We have to unplug this throughout. It doesn't matter if the switch and the power are on. If we unplug this, at least we break the circuit, so there's no volt or current passing through. When we connect this, we have 1.5 voltage here, and the current reading says 0.16 milliamperes. Okay, I have to unplug this whenever I change the voltage. Okay, now I'm going to try with 3 volts. Then I'm going to connect this again. Now the current reading says 0.3 milliamperes. So 3 volts. I have to disconnect again. Then I'll try with 6 volts. Now the current reading says 0.58 milliamperes. Now we'll calculate the resistor's resistance by dividing the voltage by the current. By calculating the voltage over current ratio, we've obtained a constant, almost constant, like we have a 9.4, we have a 10.00, and we have a 10.34, which are all constantly 10. So voltage over current ratio is always constant, and this was first discovered by Gregor Ohm, and we call it Ohm's law by his name. And this states that voltage over current is always constant, and the unit of resistance is volt over ampere, and it's called ohm, like I said, and the symbol is omega.
Well, I'm not convinced by this experiment, so let's use another resistor to check if this is truly true for all resistors.
Okay.
So over here, I'll give it when it's 1.5 volts, we When it is 1.5 volts, we can see that it is approximately 0.3 milliampere. So if you write that down. And
0.3.
And then we'll change it to 3 volts. Okay, we have 0.56 milliampere. Make it 6 volts. It is 0.96 milliampere. Okay. And right now we will calculate the voltage to current over current, which means the resistance.
I think we've made an error when calculating the values because when the wire is not connected, please unplug it first. It's 6 volt. However, when we connect the wire to the power source, the voltage reading is 5. So I think we should take 5 volts in our calculation.
Okay, correct it.
So I think now we can calculate the resistance.
Yes. Okay. From this we can observe that when we increase the voltage, like when it's 1.5 volts and the current is 0.3 milliampere, it gives us 5. The resistance is 5. And right here, when it's 3 volts, it becomes 0.56 milliampere, which then gives us 5.4. The resistance becomes 5.4. And when it's 5 volts, the current becomes 0.96 milliampere, and the resistance becomes 5.2. Okay, from this I have seen that Ohm's law is real, and our experiment has officially proven it. And so I believe that Ohm is a very lucky man to have his name imprinted in science.
Well, do you think this is luck? I mean, I think this is a result of simple systematic observation. I mean, this is how it is in all sciences and physics.
Yes, and if we work hard, our name can also be part of science literature, right?
Now that we've established that Ohm's law is real, we will move on to discuss the questions on our worksheets.
Well, before going to the worksheets, I have a basic question.
Oh, so what's your question?
What's the use of resistors in a circuit? I mean, they don't really give off light like the electric bulb or do some function like the, I don't know, like the switch.
Okay, so that's a very basic question and I'll explain it to you. Resistors are used to control the amount of current in the circuit, and in electronics that's very important because the different circuit elements need a controlled amount of current in order to work properly, so that's the function of the resistor.
Okay, now we can move to our worksheet. Right here I have a question, and it says we have two circuits, A and B, and in circuit A, the battery supplies twice energy than it does on circuit B.
You mean twice voltage?
Yes, twice voltage. Okay. Thank you for correcting me. However, the current in circuit A is only half of the current in circuit B. So we are asked to find the resistance of circuit B according to what A.
Okay, so you need to calculate the
No, I meant circuit A according to B. Yes, B.
Calculate that, but we need to use the parentheses first. If you have some space. Okay. Let VA be the voltage in circuit A, that is equals to VA is equals to resistance of circuit A times current in circuit A, and velocity in B is equals to resistance in circuit B. Voltage, I'm sorry, times current in circuit B. Now we've been told that the voltage in circuit A is equals to twice that of voltage in circuit B. So we have voltage B is equals to half of voltage A. So we can use this to drive the formula of half voltage A, voltage of circuit A is equals to resistance of circuit B times current in circuit B, which gives us the formula of voltage in circuit A is equals to 2 times of resistance in circuit B times current in circuit B. Okay, and well, we also have resistance in circuit A times current in circuit A, that is equals to 2 times of resistance in circuit B times current in circuit B. When we divide all these by the current in circuit A, we've been told that the current in circuit A is equal to half of that in circuit B. So we can use that. We have 2 times the resistance in circuit B times the current in circuit B over half of current in circuit B. Calculating this, we get resistance in circuit A is equals to 4 times that of resistance in circuit B.
So we have a choice here.
Okay, first we had voltage in circuit A, that is resistance in circuit A multiplied by the current in circuit A, and the voltage in circuit B is equals to resistance in circuit B times the current in circuit A. Now, while driving these, we have the voltage in circuit A that is twice of that of voltage in circuit B, and this means half of the voltage in circuit A is equals to the resistance in B times current in B. And we also have the current in circuit A, that is half of the current in circuit B. Driving these with easy mathematical equations, we have found the resistance in circuit A to be 4 times that of the resistance in circuit B.
So we have another question, and it says that right now we also have 2 circuits, and they have the same resistance to the current. And in one circuit, the battery causing the flow of current has a voltage of 9 volts, and the other circuit has the current on that same circuit is 3 ampere. Okay, and in the other circuit, it has a voltage of 1.5 volts, and the current, and we don't know what the current is, so we need to calculate that.
I think we can easily solve this question by applying Ohm's law. And in Ohm's law, resistance is going to be constant. So we can say that voltage 1 over current 1 will be equal to voltage 2 over current 2. This means the resistance, the first resistance and the second resistance are going to be the same because the ratio is always constant. So voltage 1 is 9 volts, and the first current is 3 ampere. And voltage 2 is 1.5 volt, and so now we need to find what current 2 is, and from this we can easily calculate the value of the current, which would be 0.5. Okay, so we solved this question by applying Ohm's law. And we first put the formula, voltage 1 over current 1 is equal to voltage 2 over current 2, which is the same as saying the first resistance and the second resistance are the same because the ratio is the same. So we put the numbers in our formula, and then we calculated the value for the second current, and we got the value of 0.5.
So our third question is to determine the resistance of a carbon resistor using color code charts.
Okay, so previously we have calculated the resistance by using Ohm's law, but there's also another method to calculate resistance, and that is using color coding. So here I have a resistor, and I'm going to calculate the resistance using the color coding. So as you can see here, the first band is orange, and the number for orange is 3 from our chart. So I write 3. Let me go through the chart. I write 3. And the second band is also orange, so I write 3. And the last band is orange, so I write times 10 to the power of 3, which means 33 kilo ohm. And we can also check the resistance by using a multimeter. And when I measured the value, I got around 28.3. So I write this down. Okay, so now as you can see, the amount that we got by using the color code is 33 kilo ohm, but when we use the multimeter, we got 28.3. So there's a bit of difference, and so we need to know the percentage. So in order to do that, we calculate 33 times 10 to the power of 3 minus 28.3 times 10 to the power of 3 over 33 times 10 to the power of 3, and our value will be 14.2%. So 14.2% is the percentage that we got by calculating it.
You mean the percentage uncertainty?
Yes, that's the percentage uncertainty.
In terms of percentage, now that we have done that, let's measure the resistance of other items. So far we have used Ohm's law and the color coding to know the resistance. Right now, let's just check the resistance by directly connecting it to the multimeter. First, we'll try the resistance of water. It's around 4.8 kilowatts. Okay. And next up, could you add some salt to this? In the meantime, I'll check the resistance of a nail. Okay, give me the salt water. Let me ask you a question. Do you think this increases the resistance or decreases than the water?
I'd say increases.
I think it will decrease the resistance.
Okay, let's try it. Okay, 1.4.
It's around 1.5.
Write that down. So it decreases. Next, let's try copper wire. So now let's see what the resistance of the copper wire is. So from everything we've got so far, from this we can conclude that the resistance of water decreases, which means when we add salt to it. Can anyone explain this?
Well, in chemistry, we've learned that ionic compounds are highly conducting compounds, and we used sodium chloride as the salt. Sodium chloride is an ionic compound, so when we add sodium chloride to the water, it obviously decreases the resistance because it's a high conductor.
That's very interesting.
The other point we notice here is that copper wire has the least amount of resistance. Can you explain that?
Well, it's because copper is a good conductor of heat and electricity.
Okay, so that's why it has a very low resistance.
Yes.
Okay, so I guess this concludes our experiment for today. In today's experiment, we've seen about resistance. From Ohm's law, we know that resistance is the ratio between voltage and current. And there are different methods to measure resistance. We can apply Ohm's law, we can use multimeters, and we can also use the color coding system to know the resistance. So I guess we've learned for together.